Welcome to TechEasy YouTube channel. Friends, in today's video, we are going to discuss about the concept of link. Okay, so what are the links and what are the types of links and how just we are able to create the links. Okay, so here, our agenda is to make links between the files. Okay, so objective of behind linking is that we can have multiple file names that reference the same file with hard links and symbolic links. Okay, so basically links can be two types. Okay, first one is hard links and second one is the symbolic links. And symbolic links is also known as the soft links. Okay, so don't be confused if somewhere it's written like if someone is asking what is soft link. Okay, so symbolic links are known as soft link. Okay, so before discussing about this topic, one important uh, topic is here. Without knowing this inodes, basically we are not able to understand the difference between the hard link and symbolic links. Okay, so that's why it's important to discuss about the idea of what is the inodes. Okay, so like when we talk about the Linux inode, so an inode number is a uniquely existing number for all the files in Linux and all Unix type system. Okay, okay. So it's also in present in Windows based operating system. Okay, so when a file is created on a system, a file name and inode number is assigned to it. Okay, so basically when our system create a file allocation table, it's create a two main field. First field is file name and second one field is inode number. Okay, so generally to access a file, user access the file names, but internally file name is first mapped with respective inode number stored in a table. Okay, so let's talk about what is the contents of inode. So basically, an inode is a data structure containing metadata about the files. Like following content are stored in the inode from a file, like user ID of file, group ID of file, device ID, file size, date of creation, permission, owner of the file protection flag, link counter to determine the number of hard links. Okay, so these are the basically metadata about a file of a file. So it's also have inode table. So if you want to our system maintain inode table, if you want to see that inode table, then we can use the df-i command. Okay. So the inode table contains all the inodes and is created when file system is created. The df-i command can be used to check how many inodes are free and left unused in the file system. Okay, so first we will talk about the creating the hard link, and then we will discuss about the limitation of hard links. Okay, so like every file start with a single hard link from its initial name to data on the file system. So when we create a hard link to a file, so basically we create another name that points to the same data. Okay, so the new hard link act exactly like the original file name. After the link is created, you cannot tell the difference between the new hard link and the original name of the file. Okay, so what are the limitation of hard links? Like hard links have some limitation. First, you can use hard links only with the regular files. You cannot use the link ln command to create a hard link to a directory or a special file. Okay, so this is the first limitation. So we are not able to create hard link of directory or any special file. Second, we cannot use hard links when both files are on the different file system. Okay, so we can only use the hard links when both files are in same file system. Okay, so it's a requirement of hard link. So second one is the symbolic link. So first of all, we will see how we are able to create hard link, and we will also see limitation of hard links. so that we are able to understand. Then we will just go to the symbolic links. So first we will create the hard links. Okay, like here you can see that our system also maintain the link. Like here you can see that a symbolic link is created for user lab 64. It means this is the linked. This is not actually present. This is just a soft link. So our system also uses soft link and hard link. Okay. So like when we just enable any service, then it's also create a link of system files. Okay. So just what we want. So just let's create a file first. So I will create a file here, like first where I am. So just cd to home directory. Okay, I will create a file here. Like I already have a file hello.txt. Okay, and I have practice 3. So just I want to see what is the content of that cat hello.txt. Okay, so its content, this is simple text. Hi, this is Saurabh. Okay. So for now, what I will do, just I will create one more file, which name will be hello1.txt. So just I will create hello1.txt. Okay. Now just try to get. I did not put any information in this file. Okay. So it not show any information. But right now, what I will do, just I will create a hard link. Okay. So what is the command? Command is like just I want to link hello.txt to hello1.txt. Okay. So it's saying fail to create hard link. File exists. Okay. So it means it's saying so first limitation is here. You can see that when we have to create a hard link, it means just here when I will do this, it's able to create a link. But when any file exists, any file is already exists, then you are not able to create, then you are not able to link that things. Okay, so this is the limitation one, and also here you can say that just here we are able to link the simple file like what just use this command lsfnltr. Okay, okay. Now here just I want to show one more thing, which is inode number. Okay, how you are able to see that? You have to use I parameter here. Okay, so here like it's showing inode. So hello one. Okay, I just link hello.txt to hello2.txt. Now just try to see inode numbers of these two files. Here you can see that both file like I just link the hello.txt with hello. I just link hello2.txt from hello.txt. Okay, so hello.2.txt is linked to the hello.txt. So here you can see that both files have the same inode number. Okay, here you can see that both file have same inode number 1743989. It means what happened when just we created the hard link. So basically, just it created a direct link. So here our hard link is also same. So what happened when just we delete the hello.txt here? So just try to just we uses the rm command. So just use rm hyphen rf. Okay. So just I deleted the hello.txt file from here. Okay. Now one more time use the ls hyphen li command. Now here you can see that hello2.txt is still here. Why? Answer is because it's did not deleted rm command, not deleted the hard link. It's just not deleted the inode number. It just deleted the file name, not the inode. Okay, so that's why. Now just try to access the hello to.txt. Here you can see that we are able to access the information of hello2.txt, which is hard linked. Okay, so now you are able to understand the concept behind the inode. It means our file is just linked with the same inode number. We have our file table have two different file name, but that file name is linked with the same inode number. So when we just delete the by using rm command, so just it deleted the file name and inode entry for that file name, not the for the second one, because that is hard linked. Okay, so this is the concept. Now let's go to the discuss the here. Like just I create a directory here. Just I created a directory for testing. So test. Okay. Now just I created a test directory. Now just I want to link this test directory to test one. Test one. Okay. So as we know, we are not able to link this, but I just want to show the limitation. So just I want to link this test to test one. So it's saying hard link not allowed for directory. Okay, so this is the limitation. And also one more limitation is present. So you are not able to link the files also that uses that are stored in the two different file systems. Like one is stored in XFS and second one is stored in uh, ext4. Then you are not able to create the hard links there. Okay, so this is the limitation. Okay, of hard link. So now you are able to understand the concept behind hard link. So if you want to just link any file, so it's also very useful when you don't want to delete your data. Okay, so you are able to here when you just create a hard link of the same file, so it just mm, stored at one place. Okay, but when we just create a hard link, then if some user by mistake delete any file, then our file 2 is still exist and we are able to access that. Okay, so this is the concept. Now just go to the soft link. Okay, like here I already discussed the limitation. Okay, I did not have two different file system. So when we create two different file system and want to show you, then it will create a lot of time. But it's 100% sure it's not work with the two different file system. So you have to learn this and keep in mind. Okay. So how we are able to create symbolic link? So just we have to give the hyphen s option with the ln command. Okay. So the ln command happens as option create a symbolic link, which is also called a soft link. So a symbolic link is not a regular file, but a special type of file that points to an existing file or directory. So if you want to just link to directory or to a special file or to existing any file, then we can use the soft links. So symbolic links have some advantages over hard links. Like symbolic link can link two files on different file system. Okay, and symbolic links can point to a directory or a special file, not just to a regular file. Okay, so it's basically uh, remove all the limitation that any hard links have. Okay. So always our system is also uses the soft links. Okay, or symbolic links for linking their file. Okay. So just we see by an example. Okay. And we will also discuss what are the differences between those. As like here, two differences are clearly here. So we will see one more difference at inode level. Okay. So Alex here, like here we create two files first of all. Not two files, just one file here. So here, as I already have hello.txt, like I deleted hello.txt, so I have hello1.txt or hello2.txt. So just get hello2.txt. So for this, I just use the hello2.txt. Okay, so this content which is simple text, and this is corruption. Okay, so just I want to create a soft link. So what I will do, so just I use hello2.txt and just here hello3.txt. Okay, so just I created a soft link now. Okay, just use this command. Sorry. So here you can see that now hello3.txt is soft link to hello from hello2.txt. So just try to access the data of hello3.txt. You can see that we are able to access the same data also. Okay. Okay. So one more important concept about hurdling, like it's just um, our file system file name is mapped to the same inode number. So uh, when we create hurdling, then it shares the same permission. Okay, it's also case with this. So just now I want to see the just I want to see the inode number. So just I use the ls icon. I like are the symbolic links. So here, like we can see that hello2.txt and hello3.txt has different inode number. Okay, here you can see that. So it can share different file permissions, but this is not case with the hard link. Hard link must share the same file permission. Okay, but here we can give the different file permission on hello3.txt. Okay. Okay. So here one more thing, like when we just delete hello3.txt, let just remove the hello3.txt. So it's saying remove symbolic link hello3.txt. Yes. So just we deleted the symbolic link. Okay, here you can see that we just remove the symbolic link, but we just try to access the hello2.txt. So we are still able to access the hello2.txt. Okay. So one more time, just I create the soft link by using the same command. I just want to link hello2.txt to hello3.txt. Okay. So now just we try to access the hello3.txt. Okay. You can see that we are able to access the content of hello2.txt within hello3.txt. It means our soft link is working fine. So now what we will do this time just I will remove the main file which is hello2.txt. Okay. So now just see the output of this command. Now this turned into the red. It means this is called broken symbolic link. Okay. Now when we try to access, hello3.txt. So here it's saying no such file or directory. Although we are able to see here hello3.txt is present here, but due to broken link, we are not able to see. So when we delete the main file in soft link, then it's just create a broken link and we are not able to access the that file. But this is the not case with the hard link. Okay, so now I think you are able to understand one more point. When just we deleted the main file that are hard linked, then we are able to access the linked file because they are hard linked. Okay, they are just mapped with the same inode number, but they are mapped with the different inode number. So when we remove the swap linked file hello3.txt, then we are able to access the hello2.txt. Does not affect the hello2.txt. But when we just delete the main file hello2.txt, it's create a broken link and we are not able to access the hello3.txt. Okay, so just what we will do, just we will create one more time hello2.txt to complete this link. So when you see this type of broken link, then you have to understand, you have to, you just by mistakenly deleted the main file. Okay. Okay, hi, this is links class. Okay, I want to make it to hello2.txt. Okay, okay. Now just check the output of ls-li. So here you can see that now our link is not a broken link. It's basically reconverted, or recharged into its main state. Now, what will we will just try to access the content of hello3.txt this time. So this time you are able to see that our content of hello3.txt is changed. Now it's just pointing to hello2.txt's current information. Okay. So this is the all idea of top link and files. Also, we are able to soft link the two special directory uh, on different file systems also. Okay, but hard link are not work with two different file systems. Okay, hard link only work on the same file systems. So just now travel to like here if I want to show example of soft link that are mapped with directory. So just I go here, like here, you can see that our system also uses the soft links for linking their files. Okay, here like you can see that lib is linked to the user lib. Okay, so here uh, uh, soft link is already created at directory level, but just I want to show you how you are also able to create the same link and able to access the content. Like just I would like to copy the etc to root. Okay, now ls here, I hope root is here. Okay, etc is here. So we just copy the etc directly to here. But now what just we want to do, just I will go here and here I will create a directory. Okay, just need not to create a directory, just I will directly map. Okay, what next we will see here. Let first we create a directory. So just I created a directory name configuration config. Okay, Just as create a directory name config. Let I want to use soft link for linking this. So I want to link root etc to root, not root. Just I want to link these two files. Okay. So just be here. Okay. So what is showing where we created the config. Just let me see. Okay, config is here. Okay, config is here, but it's not actually linked with anyone. Okay, so now just give the command like ln. Okay, just I want to link etc and okay, etc to config. Okay, so just I use this. Now just cd to config. Here you can see that etc is present here. Now ls here, you can see that all data is present here. So just we go here and here just I use ls-li command. Here you can see that our etc is linked with root etc. Okay. So here what just we do? So just we link the uh, two directories. Okay, like here just I link etc to root etc. So when just we go into the config, like I am in config directory and just I change to etc. Here you can see that our all the configuration is present here. Okay, so just we created a soft link. Okay, of configure etc. Okay, to root etc. So that's it. So in the manner we are just able to create a soft link. So just cd to root. Okay, will not show here. So just we created this link here. That's why. Okay, at config. Sorry. So here you can see that you can recognize any soft link just by seeing their color also. If color schema is applicable. Okay. So like here our this etc is a soft link. So how we are able to see that? Just use the ls-li command. Okay. So it's saying etc this etc directory is soft link to the root etc. Okay. So this is the idea of soft links. Okay. When you delete the root etc, it is also create a broken link. Okay, so you are not able to access the etc file. So same funda is also applied here. Okay, so what is the real life use cases of this links? Like this link can be used like here. Just I have a complex directory structure. Like I have to go every time. Uh, I have a web server, and that web server uh, directory structure is very lengthy. It means we just have to go in very depth to access the index file. Okay, just I here I just want to show example here. Just I go here and I have a configuration file in etc. Okay, so just I go here and I here I have to go repos. Okay, okay. For now, just I want to show the how you are able to make the your M repos to a simple file, simple directory. Okay, so that you don't have to go into deep. Okay, like here you go here and then here you ls here and you got the my repo. So just you got this my dot repo file. Okay, here, sorry. Okay, so here what we can do this, we can just create a simple soft link for this file. Okay, and we can just put into the user home directory so that any user is able to access this in very easy manner. Okay, or very easy manner. Also sometimes our system wants some specific version of any file, then we can just link that file. Just we can create the soft link and that is okay. So here, just I think I able to understand, able to explain everything. So you have to keep in mind you can create a link. How you just able to create the link? Scenario maybe in real time maybe change. Like sometimes if you want or you are not getting the exact version of module, but you install that many version of module, then we can just create symbolic link for uh, calling that module so that in the manner you are able to solve the module mismatch problem or version mismatch problem. Okay, this type of problem can be resolved. Also sometimes you can create a hard link to protect your data by accidentally deleting. Okay, and also sometimes you can just create a simple symbolic file to call any lengthy file. Okay, like here if you want to just call m dot my repo file, so just you can create a link. Just I go here in root, just I change to root and just I will create a simple link of my repo file, like by using this ln-s command. Just etc yum dot repos dot d. Okay, and there my repo, I just want to link this with my dot repo. Okay, okay, just I go here and just what happened. So just I if I want to edit this, then just I go here and able to edit this. Okay, so we are able to access the my repo. In the same manner, we are also able to create hard link. Okay, so now you can see that my repo is accessible from here. Okay, so this is the basic funda. This is not the real real life scenario use case, but you can think about that scenario. You can just take an idea from here. Okay, okay, that's it for this video. Okay, thanks for watching this video, friends.